Okay, so this is the video for the 1-2 chemistry assignment. The first video, there's probably going to be two. And if you've gotten to this point, hopefully you recognize that you need this form for completing this assignment. And you've also probably recognized that there is no Nearpod for this. I'm just going to have to go without Nearpods for a while because it just takes too much time. So for at least a little while here, you're going to have just videos and scrolling through the notes and me writing on the screen as we go through the lectures. So if you are here, you obviously went to assignments, clicked on the video, and hopefully have your sheet in front of you. And let's see. So if you go to course outline and then you go to this particular lesson, 1-2, you end up here. And also notice that I've added a periodic table. And also notice that it's in a different tab so that you can switch back and forth. And you have a couple of starter kinds of questions here. I'm sure you are probably aware of the answers to these questions. But what do we call the prominently displayed whole number in the box of each element listed on the periodic table? In other words, what do we call this number, 5 or 6 or 7 or 47? What are those numbers called? And then the second question here to start thinking about is what property of the element is this number based on? Is it based on number of electrons, mass of the atom, number of protons, or number of neutrons? And that's kind of the first learning target we have here. You will understand that elements in nature are composed of unique atoms represented by a unique name and atomic symbol. And we know that these are on the periodic table, the names and the symbols. And you will also recognize that these elements are organized according to the number of protons, and they're organized into a table that we call the periodic table. The reason that we're going to do this is that because this is foundational. All of chemistry begins with learning of the basic structure of atoms and the system of naming and how these features are displayed on the periodic table. So you will be able to accurately state the names and corresponding atomic symbols of all the elements and be able to locate any element on the periodic table and identify the basic information about each element that the table provides. Okay, so let's go back to this. So when we're talking about elements then that we're looking at on the periodic table, again, we symbolize these by use of atomic symbols. Okay, the atomic symbols are 1 or 2 letter alphabetic codes representing the name of the element. You're aware of this, and if I go to my periodic table, I can see all these symbols. So the symbol for aluminum is Al, the symbol for mercury is Hg, for iridium is Ir, and so on. And so atomic symbols is what goes in the answer there, and you can just kind of hover over this as well as yourself. So atomic symbols. And then elements are organized into of course, periodic table. So that's what goes in that answer there. And recognize that not everything in the class notes canvas are going to be something that you won't be able to find that answer necessarily to try to fill out the form without looking at the video, because there will be some information on the video that's not on this set of class notes. And then the property of the atom that determines that sequential position on the periodic table, we've already said, is the number of protons. Okay, so number of protons is what's going to go in that third answer sheet. Okay. And just to begin to get you started in looking at and recognizing the features of the periodic table, look at the list of elements below and their corresponding atomic elements or atomic symbols, and then take a few minutes to search the table for the atomic symbol and identify the sequential whole number present within the elements box and write this down. So you've got a periodic table at your disposal. Again, this is over here, and then when you finish that, writing all those down, come back to the video, and then we'll go through this together. Okay, so I'm going to go ahead and pause the video and let you do that. Okay, so I'm assuming that you have completed this task. I'm going to go to a page where I can write information down as we kind of walk through this. And let's see if I can find a way to get the periodic table back and forth here. Okay, that should be able to allow me to do that. So first was aluminum, and you see aluminum is element number 13 there. So write down element number element number 13. Then bromine is over here in this column, column 35. And write that number down, or column 30, it's atomic number 35. Go back to my periodic table. Calcium is over here in 2A. That's element number 20. Oops. And then carbon is going to be element number 6. And then chlorine is going to be over here in column 7A. So that's element number 17. Cobalt is going to be over here at element number 27. Then copper is going to be here, element number 29. And then after copper is fluorine. Fluorine is going to be number 9 over here. And then we're going to find gold. Gold is going to be number 79 right here. Then you should already know that hydrogen is element number 1. And then as we go further, iodine is going to be number 53. Then lead is going to be element 82. The magnesium, I can already tell you, is going to be element 12. The mercury is going to be down here. Hg is number 80. And then nickel, number 28. And then I'm just going to let you make sure that you filled in the rest of these and move on from there. Okay, so as you go through time, you'll be able to figure this out more and more, and it'll become faster and faster to you as you become more familiar with the periodic table. So as you should already know, the element, the number that we're finding here is this element's atomic number. Okay, so the next thing that we talk about are, we can figure out what the names of elements are. What about the compounds? Once we know what the names or the symbols for the elements are, we can put these together in chemical formulas, and we'll learn how to do that later on. But I need you to be able to look at a chemical formula right now and tell me what the number of atoms of each element are in that chemical formula. And so think about it. How many total atoms are in this particular element here? And think about it for a second and write your answer down. And then I'll talk about the learning target for this particular thing. So you'll understand that all pure substances can be represented by a chemical formula, and you'll know how to identify the number of atoms of each element in the chemical formula. You'll understand the chemical interactions between pure substances involve the breaking of chemical bonds and the formation of new chemical bonds in a process called a chemical reaction. And then chemical reactions can be represented by sequences of chemical formulas called chemical equations. So the reason we're doing this is that in order to understand interactions between elements and compound structure, you need to be able to understand and use the language that describes these. And I will expect you to be able to use and write chemical formulas with 90% accuracy in situations requiring their use. Okay, so all pure substances, whether elements or compounds, can be designated then by a chemical formula. That's the whole point. We're making sure you can read these chemical formulas. An atomic symbol. Okay, I'm not sure why okay, there it is. An atomic symbol represents each element in the formula. So in this formula down here, C represents carbon, H represents hydrogen, O represents oxygen. And if the substance is an element, the chemical formula is just the atomic symbol. Okay, so if I just have carbon, I just write C. And then...
Morning, teachers. We're just checking something on the ETA system. So thank you for having a great day. Bye.
So I'm hovering over this one, and a blank, there it goes. So a subscript is the answer that we're looking for here. I'm not sure why that's not coming up either. A subscript following the symbol indicates the number of atoms that the element of that element present in the formula. If no subscript follows, it's assumed that the number of atoms of that element is 1. So it kind of keeps flashing there, doesn't it? But it's not coming on. So here's a chemical formula for glucose. What atoms are present in the molecule and in what numbers, and then we'll draw the glucose molecule afterwards to confirm this. I'm coming up on the end of my 15 minutes for this video, so I'm going to stop this video and we'll come back here when we're done, when I start a new one.